Hi everybody, welcome to another video in Business Calculus section 10.4, the chain rule. This is very important section. This chain rule allows us to find derivative of a lot more functions, in particular composite functions. A function m is a composite of function f and g. If we write f of x is equal to f of g of x, the domain of m is the set of all numbers x such that x is in the domain of g and g of x is in the domain of f. So we have start from x, we have g of x, and then we will have f of x. And m of x will go directly from, I should say, f of g of x. So x go to g of x, and whatever g of x is, go to f of g of x. And m of x go directly from x to f of g of x. Right, so let's look at the first example. Let f of x be e to the x power and g of x be negative 3x plus 1 for f of g of x. So f of g of x meaning that we're going to put g of x into the x of f of x. So simply we put negative 3x plus 1 into x. But in general, let's say, let's start with very fundamental. If we start with the function like that, meaning I'll just say whatever you put in this parentheses could be x or whatever, we do the same thing on this parentheses. So that would be the same, right? So I'll replace the x here and the x here by the parentheses. And then if I put g of x here, I'll put g of x there, right? And then g of x is equal to negative 2x plus 1. Yeah. So I will say this is equal to e to the negative 2x plus 1. We really don't need to write the parentheses there, right? So simple enough. Now we have g of f of x. So the function g is this. So I will write the function g. Instead of write x, just keep a space. And then have negative 3 times the parentheses. Then plus 1. Right? Now if we put f of x in it, we put f of x in this parentheses as well. And that gives us negative 3. F of x is e to the x power plus 1. So we will have negative 3 e to the x plus 1. Right, so that is composition. Now we decompose it, meaning we go the opposite direction. Can we write this as a composition of the other two functions? Well, it is easy. So we'll say, we can just say this is a parentheses to the fifth. If we ignore what in the parentheses, then we say the parentheses equal to x cubed plus 1. Yeah, so we decompose that in two functions. And in that case, the parentheses, we can change, how about put u here and u there. So we have one function is equal to x cubed plus 1, so we can say g of x. The second function is equal to 2x cubed plus 1. And the first function, the other function is something to the fifth. And so we say g of, f of u equal to u to the fifth. But you can also say f of x is equal to x to the fifth. You can also write f of u is equal to u to the fifth. but that's what we have. So the key here is just to decompose the function into two functions. Like if we put the parentheses around like this, we will have 1 over a parentheses, and the parentheses is equal to x to the 4th minus 2. Because you can say u and u or whatever it is, but the second function is 2x cubed plus, I'm sorry, x to the 4th minus 2. And the function before that will be the reciprocal function 1 over x. If we want to, the variable doesn't really matter, we can just say it, u as a variable. And that works perfectly. Like I said, the variable here doesn't really matter. The function is whatever we substitute there, same variable. Let's just keep in that form. Right, now here we can say, put the parentheses around the 3e to the x minus 4. So we'll have the parentheses, square root of the parentheses, and then the parentheses is equal to 3e to the x minus 4. And then we have u and u. So we can say the second function is 3e to the x minus 4, and the function before that, if let's say in terms of u, is square root of u. Like I said, we can write any variable here. If that is w, then we write f of u, f of w, or x, and x doesn't really matter. By the way, it's just the way we choose what we put in the parentheses. I could potentially choose something else if I want to. So I put the parentheses around e to the x. So I have the parentheses 3 times the parentheses minus 4, and then the parentheses is e to the x. Yeah, we can choose that too, right? And then, like I said, the variable doesn't really matter. You can say v. In that case, the second function in terms of x is e to the x, and the function in front of that is square root of 3v minus 4. It just doesn't matter what we choose the parentheses to be. That will be the second function, and from that we have the first function. Right. Here we can say we put the parentheses around negative x squared plus 3. So we have 5e to the parentheses, then the parentheses equal to negative x squared plus 3, right? Any variable will do. So u. So our first function is 5e to the u, and the second function negative x squared plus 3. Right, so that how we decompose the function. Just put the parentheses around something, and then we get the second function, then the first function after that. The chain rule is important to know how to decompose a function, so we can use the chain rule. The chain rule says derivative of the combination is the product of derivative of y with respect to u and derivative of u with respect to x, or just write like this. Right. So I will do two different ways here. One is rely on choose a variable, and the other one is more abstract, and then we don't even use the formula. I recommend you to do the second way. Right. As first, let's decompose this. Right. So we will do two different ways. So if we decompose this, the parentheses to the fifth power, and then the parentheses is equal to 2x squared plus 1. Right? Because we can put u. Right, so that we decompose it. Now we take derivative. Derivative of this is just 4x. And we check derivative of u to the fifth is 5 u to the fourth. And the chain rule says we find the product of those two functions. That gives us derivative of the computation. That is a chain rule. Of course, we don't have u in the original function. We just have x. So we substitute 2x squared plus 1 into u. And we can multiply the 4x and 5 together. That gives us 20x. Parentheses 2x squared plus 1 to the fourth. Right. So that is when we use the chain rule with the substitution like this. Later on, I recommend that we don't even use that. We use even more abstract idea without using u. So we start something like this. Just assume that you don't have anything in the parentheses. Forget what happened in the parentheses. Or we say the parentheses is a variable. So derivative of the parentheses to the fifth, something to the fifth, we say derivative is 5, the parentheses to the fourth. Right? Doesn't matter what inside the parentheses, derivative of the something to the fifth is that. Right? And then we will have derivative of the parentheses. The chain rule, the difference is we have derivative of the parentheses. So we just go ahead and write like that. Doesn't matter what in the parentheses. Derivative of some that to the fifth is 5 times that to the fourth. And then chain rule says multiply derivative of the parentheses. This doesn't matter what inside the parentheses. Now inside the parentheses happen to be 2x squared plus 1. Right? So we rewrite 5 to x squared plus 1 to the fourth. Now we do this derivative, give us 4x. And then 5 times 4x, that's 20x. 2x squared plus 1 to the fourth power. You see, it's more direct, and we don't have to rely on the middle variable, intermediate variable. Right, this one, let's try that again. Right, if I put the parentheses around x cubed minus 1, right, the parentheses is x cubed minus 1, and we have square root of it. Now if we have u, and then we just take derivative of x cubed minus 1, derivative is 3x squared square root of u. If we take derivative of that, and we can use the power rule, we write square root of u as u to the 1/2, then that is easier to take derivative. It will give us 1/2 u to negative 1/2. So that is the derivative. So we have 1/2 u is x cubed minus 1 to negative 1/2, and then 3x squared. If it is 3x squared, we can just write that multiplying the single term with 3x squared. So that gives us 3x squared on the top over 2. X cubed minus 1 to negative 1/2. Right. Now again, I'm going to do just using the parentheses here. And rewrite it. Y equal to square root of x cubed minus 1. And since we're going to use the power rule anyway, I will write square root equivalent to 1/2. Right, now we take the derivative in that form. So once again, doesn't matter what inside of the parentheses. If it is to the 1/2 power, the derivative is 1/2 of the parentheses to negative 1/2, and then the derivative of the parentheses. Doesn't matter what inside the parentheses. That's how it works. Power rule and then the chain rule, always time derivative of the parentheses. Right? Just happen to be x cubed minus 1. So we have 1/2 x cubed minus 1 negative 1/2, and that will be 3x squared. And of course we should have the same thing as before. So 1/2, I'm sorry, the 3x squared on multiply on the top. And then x cubed minus 1 to negative 1/2. Right, from now on, I'm just going to do the derivative in that form. So, if we make it clear, we can put the parentheses on the exponent here. So we have derivative of e to something, that is exponential rule. That to parentheses. So derivative of e to something is the same thing. And chain rule says multiply by derivative of whatever the parentheses is, which is negative 2x squared plus 1. Alright, so e to the negative 2x squared plus 1, and this is negative 4x. Just the derivative of it. Then this is negative 4x. If we write that in front of the e, we don't really need the parentheses. So that's what we have. Right. So I recommend to do the problem like this without writing the intermediate variable. Right, it's more of it. Right, we have 5 over 4x squared plus 3 squared. Of course, the parentheses is 4x squared plus 3. That's obvious. But if we take the derivative of that, it is easier to rewrite this as the power. So we can use the power rule. So we're going to say 5. The parentheses at the bottom square, we say to the negative 2. If we move to the top. And inside the parentheses is 4x squared plus 3. Right? Let's move that from bottom to the top. Change the exponent from 2 to negative 2. Right. Now we have the power rule. Derivative of something to the negative 5, something times negative 2. We take down the negative 2, original power minus 1. Right? So that is, doesn't matter what inside the parentheses is. It's going to be like that. Yeah. Something to negative 2. Take the negative 2 down. Original power minus 1. Minus 2 minus 1 is minus 3. Minus 2 subtract 1 is negative 3. Right? Inside the parentheses is 4x squared plus 3. So that gives us negative 10. 4x squared plus 3 to negative 3. And the derivative of this is ax. Now, if we have just one term, we can just multiply them together. And that gives us negative 80x. We write like that, we don't have to run extra parentheses here. Right, so here we have ln of a parentheses. So derivative of ln, the natural log, derivative is 1 over the parentheses, and we take derivative of the parentheses. Right? Doesn't matter what inside the parentheses is. 2x to 7 minus x plus 5. So we have 1 over 2x to 7 minus x plus 5. Derivative of this is 14x to the 6 minus 1. Right? And I just multiply that to the top. We can write 14x to the 6 minus 1 over 2x to the 7 minus x plus 5. Right, so that same thing here, we have a parentheses log base 2, right? So in general, what is the derivative of log of some other base of x? Well, that is 1 over ln of the base times x. Right, so we have the log base 2. So 1 ln of 2. And then the parentheses, derivative of it. Doesn't matter what inside. What inside is e to the x plus 3x. So 1 over ln of 2 e to the x plus 3x. 3x, not 3 to the x. Now time derivative. E to the x, derivative of e to the x is itself. Derivative of 3x is just 3. Right, so we have that. Once again, if we can multiply to the top, do that. right? So that's what we have. Next we have this, slightly more complicated, but should be able to do that, right? Okay. Now, if we put the parentheses on the exponent, right? So we can say derivative is e to the parentheses and derivative of the parentheses times it. It just happened to be square root of x squared plus 1 in the parentheses. Right? This will be the same. Write the derivative of this, well, but not directly, but we can write that as the 1/2 power. We still have the derivative sign. If we don't take derivative, we still keep the sign. It's perfectly fine. I'm just saying about we just rewrite this as x squared plus 1 to the 1/2. Just rewrite it so the derivative still there. Now I apply the derivative rule. So we have something to the 1/2. So derivative is 1/2. That bracket to negative 1/2. And derivative of the bracket would happen to be x squared plus 1. Right, let's clear this, simplify this. X squared plus 1 to negative 1/2, and derivative of this is 2x. Now just simplify things. We have 2x and 1/2 multiplied together, and that gives us x, right? 2 and 2 cancel out, and then x. So when we multiply now, we just have a single term. I recommend that we combine them, so we don't need to write the parentheses. That's self. That if this is to the 1/2 or whatever power, we cannot combine them. But if it's just inside the parentheses, just one term multiply together, just have x. E square root of x squared plus 1, and then x squared plus 1 to negative 1/2. Right. Before we go any further, I just want to make a little comment about this. So on this one, we actually make the computation as follows. So what we do is, first we set e to something, and that something is square root of x squared plus 1. Let's put u or v, doesn't matter, let's use v. And then we can break it down even further. Break this, we have e to the v, and we can break this into 2, and we say v is equal to square root of another parentheses, and the parentheses is x squared plus 1. We can put u in that case. So we say e to the v is square root of u, and u is x squared plus 1. So x squared plus 1 is u, take the square root, put in the exponent. So in this case, we have the combination of 3 functions, 1, 2, and 3. So that's why we call the chain rule, because the chain of function could be long. But the idea is, I said, relying on this kind of complicated. We just go by that and say put the parentheses, and then we can take the derivative of that. Now if you put the parentheses differently, we won't be able to do that. For example, if we put the parentheses just around x squared plus 1, we have e square root of the parentheses. we cannot really take the derivative of this. We can only take the derivative of e to something. So that's why we go with this, that computation first. Right. So sometimes we have to make the computation and then another computation inside that. Right. Now don't jump right ahead and say derivative of ln of that, and then we just go straight to find derivative. Even though we can, derivative of the parentheses, ln of the parentheses is 1 over the parentheses, and then derivative of the parentheses. That certainly works. What I do, instead of that, just take one step back and say, what if we have the ln of a difference? It is equal to the difference. ln of quotient, we can write as the difference of the ln, right? So let's start with that. Just rewrite the function x to the 5th minus 1 subtract ln cube root of x. Now the cube root of x, if we rewrite that is x to the 1/3. We check the 1/3 outside. One-third ln of x. Right. By the way, the properties that we use, take the exponent outside. That. Now we take the derivative of the ln of something is 1 over reciprocal of that. I mean reciprocal of that times the derivative of the parentheses. This is just ln of x, so the derivative is just 1 over x. So x to the 5th minus 1, x to the 5th minus 1. And the derivative of this 5x to the 4th. And 1 over 3x. I can multiply that on the top. One over 3x. Right, so that's good to know. Like I said, don't just jump right ahead and then use the chain rule directly, especially when there's ln. There's a way to simplify things. Do that first before we find derivative. Right, the next one, we have the product one. We can find derivative of e to the negative 3x plus 1. We have to use the chain rule, and then that the product. So this is the product, and the inside that is the chain rule. So there's u and there's v. Excuse me. U is equal to x squared, and v is equal to e to the negative 3x plus 1. Right? Derivative of u is 2x. Now, there's the reason I don't want to use u and v when we take derivative. I just want to keep the parentheses, because if we use the u and v, there will be too many variables that we get very crowded quickly. So I just put the parentheses here. I said derivative of that is e to the parentheses times the parentheses, derivative of the parentheses. This gives us just -3. So multiply in front, we have -3 e to the -3x plus 1. Right, now we have the product. Derivative will be product rule. Right, u prime 2x v that plus u x squared times v prime -3 e to -3x plus 1. So you have 2x e to the -3x plus 1. And yeah, you can just leave it like this. If you want to make oh sorry, I wrote that terribly. Remember the plus 1 is on the exponent. Right, be mindful with that. Right, in that case, x squared, if I wedge right between then that, so we don't have to write extra parentheses, and that's still clear. That we multiply -3, we multiply to x squared, and then we multiply to that. Right, so again, if we just have one term in the parentheses without any power, we might want to combine them, move things around, so find a way to reduce the parentheses. So this example shows that sometimes we have the product rule, quotient rule, inside that there's the chain rule. Or from here we can say there's a chain rule, and inside that is the quotient rule. If we do that way, it could be complicated, right? Right, we end the section with an application. So how do we find the derivative of this? Because that's easy. If we rewrite this as the square root as a 1/2 power, we use power rule, but still we need the chain rule. 6 plus, I just rewrite the function, haven't done anything yet, for x plus 4 to the 1/2. Alright, so that is the function. Now we take derivative. Derivative of a constant 6 is 0, and now derivative something to the 1/2. I check down the 1/2, the parentheses, and then the parentheses, check down the 1/2 original power, subtract 1, and then we have derivative of the parentheses. Take down the 1/2 original power minus 1. I just have 4x plus 4 in it. So 1/2 for x plus 4 to -1/2. And derivative of this is 4. Right. Now, if we like that, when we just have one term without anything, we can just combine the single term together. 4 times 1/2 is 2. For x plus 4 to the -1/2. Right, so that is the derivative. Now we just evaluate at 15 and 24. So derivative at 15, simply we just put 15 into x. right? Or I just do this. It's the function, let's say 15 store into x, and then we have 2 times 4x plus 4 to negative 1/2. So that's 0.25, which is 1/4. And now we take the derivative of 24. 2 times 4 times 24 plus 4. Right, now just store 24 into x. And we do the same thing. And that. Okay, interpret the result. Well, we have C is the cost. If we take the derivative, that is the marginal cost. So the marginal cost when the production is 15 X camera per week. So the production of X 15 at the level of producing 15 cameras per week, the marginal cost is $0.25 $100, so $25. And the marginal cost of 24 is 0.2, meaning that at the production of 24 cameras per week, the marginal cost is $0.2 $100, meaning $20. Right? So with that, we finish section 10.4. As always, thank you for watching and see you in another video in business calculus.